And the last one that I have for you today, and this is a new one, is the corresponding angle converse postulate. And the converse part of it is what's new. And whenever you see converse, it just means, backwards. So whereas before when we were doing our corresponding angle postulate, we had two parallel lines and a transversal, and then we could say that the corresponding angles are congruent. Well, now that we're doing the converse, we're doing that backwards. So now we just have two lines. Notice it doesn't say anything about parallel. So we've got two lines and a transversal, and then you've got a pair of corresponding angles that are congruent. So if we take a look at that, so let's say we've got 1, 2, 3, 4, 5, 6, 7, 8. And if we know that the corresponding angles are congruent, so let's use 3 and 7. So angle 3 would have to be congruent to angle 7 based on what they showed in the picture or what you were able to show with your math. If we're able to show all of those things, I'm going to label the line A, B, and this one T for transversal. If we're able to show that 3 is congruent to 7, then you could say that A is going to be parallel to B. So basically, when you're using converses for these, you're trying to prove that the two lines are parallel. And what that will look like in a proof is you'll have all this stuff going on, and then the very last step will be P is parallel to Q. Line P is parallel to Q. And the reasoning will be the corresponding angle converse postulate. And then I think some people will put the converse in front, so the converse of the corresponding angle postulate, it means the same thing. It's just a different way to write it. Alrighty, so everything that we've talked about so far this semester is considered fair game for the proof. All of the definitions, all of the theorems and postulates, and all the ones that I'm going to give you are going to be fair game for proofs that we're going to do in the future. So you'll notice these are all lists of good reasons that you could have for a proof. So the given, it's always going to go first. If it's not the first step, it's not going to be anywhere else. That's the only place that it can go, is the first step. You will get some people who will put the given in other places, so it is possible, but probably 98% of the time, the given is going to be the very first step. So you can see all of these words that we've talked about. And whenever you're looking at a definition, the place that you use a definition is when you're thinking, well, that's what it means. That's probably going to be a definition. And you can use these two interchangeably. So you can go definition of linear pair, or you could also say angles forming a linear pair to sum 180 degrees. Those two are interchangeable. And then also definition of vertical angles or the vertical angle theorem are interchangeable too. This is one that I tend to use more, but I think our exercises uses that one. And it's the same for this right here. So I'll tend to use that one more, but your exercises will use that one. So there's our algebra properties I talked about. The definition of congruence, which is basically just a way to switch between equals and congruence. So if you have one step where you've got angle A is equal to angle B, and in the very next step they've got angle A is congruent to angle B, that's going to be your definition of congruence. It's kind of like translating between English from England and English in the United States. So a lot of the things are very, very similar, but they're two slightly different things. It's the same thing when you're looking at congruence for geometry and equals for algebra. They're very similar and they share a lot of the same rules, but they have some very distinct differences. So once in a while you'll have a case where they're going to want to switch back and forth, and that's what it'll look like. And it can go both ways. So you can go from equals to congruence, congruence to equals. And there's your reflexive symmetric transitive properties, substitution, and then there's the corresponding angles, those two lines in a transversal. And then you can do the converse for all of them, but the most used and the one you're probably only going to see is the corresponding angle converse postulate, so that's why I told you about that one. Alrighty, so looking at examples. So whenever you're looking at these, you kind of, with the fill in the blank ones, you've already got somebody's line of thought going. So it's like you're looking at a problem that somebody started and you kind of have to think your way through what they have before you can say for sure what they're doing. So for looking at this, it says complete the proof that the measure of angle XWY plus the measure of angle RTU is equal to 180 degrees. So they want us to complete the proof. So this is our proof. This is what they want us to show. So if you notice, that's going to be the very last step. Given is always going to be your first step, and your prove is always going to be the last step. So I like to look at what they give me to start with and then look at where I'm going. So to start with, they want me to show that Vx, so line Vx, it's right there, is parallel to SU. And they showed that in the picture with those little arrows right there. So I don't need to put any marks in it, but I always like to double check. Okay, so that's our given. That's where we're starting, okay? So then next, given those parallel lines, they tell us that XWY, so that angle right there, is going to be congruent to UTW, to that angle right there. Well, if I look at those two angles are corresponding angles, and it matches. The reason that they gave is the corresponding angle postulate, okay? So for the next one, they say angle RTU. So I'm going to use a different color. So we're looking at RTU plus the measure of angle UTW. UTW. So this one right there is going to be equal to 180 degrees. Okay, well, yeah, that's true because this is a line and those two angles are a linear pair. And so I would normally say definition of a linear pair, but what they do in this section is angles forming a linear pair to sum to 180 degrees. So that's what it is. So we're good so far. And then for the last step, well, right here, we're really close to where we want to go. If you look, here's the RTU. There's the RTU, and there's the 180, and there's the 180. So the only thing that I have that I don't want to have is this UTW. So instead of the UTW, I want the angle XWY. So if I look, is there anywhere in my proof where I've said that UTW is the same thing as angle XWY? There is. It's back up here in this statement right there. Right there it says UTW is the same thing as angle XTY. So instead of UTW, we can write the measure of angle XWY plus the measure of angle is RTU is equal to 180. So if you look, the only thing that's changed between those two steps is instead of this, they wrote that. And if you remember, that's our substitution property. So that's our first example. Looking at the next one, and I'm going to keep our list of good reasons right by the paper while we work them out so that I've got a list of things to pick from. So looking at the next example, they tell me line VX is parallel to line SU. So this is our starting point and this is our given. they want us to show that angle STW is congruent to angle TWX. This is our proof. So this is our start, that's our end. And just to double check and make sure that they've got what we need, there's the start, and the given, the reason for the given is given, and then there's our proof, or where we want to go, the TWX. Okay. So if I look at my picture, they tell me that VX, so there's VX, is parallel to SU. And they didn't show that they're parallel, so I'm going to put little marks in to show that they're parallel. And where I want to go, I want to show that angle STW, so I want to show that that angle right there is congruent to angle TWX. So the big mistake that people do is they won't read through what's happening math-wise in here, and then they'll just go, up, those are alternate interior angles. And if you look in the drop-down box for this, it'll actually give you the option for alternate interior angles, and that's going to be wrong because that's not the math that's happening here. So you've got to work through the math that's happening here and then use the reasoning to back up this math, not what it looks like in the picture. So given these two angles, we want to show that those two are going to be equal to each other. So what they did is they used the corresponding angles. And that's usually, if you're going to write this proof all by yourself, this is where you're going to start. If you're going to show that any of the theorems are true for our angle relationships for the two lines in a transversal, you're going to start with the corresponding angle postulate. So that's where they started. So they've got angle TWX, so TWX. So, ooh, that's one of the angles that we need. And they say that it's congruent to RTU. So they know, since we have two parallel lines and a transversal, we know for sure that all of the corresponding angles are congruent. So honestly, they could have done any of the corresponding angles, but they chose to do those two. So that'll work. So this is definitely one of the angles that they want to have. But the other angle that we want to have is we want to have this one in our proof. So what they did was they thought, so if I want this angle, how is the angle RTU related to STW? Well, those two are vertical angles. They're directly across from each other. So we could say that they are congruent, and that's what they did. They did RTU is congruent to STW. And we know for sure that's true because of our vertical angle theorem. So then at this point, they probably went back and said, okay, where do I want to go? This is where I am, and this is where I want to get. So I've got STW. Here's STW. I want to have angle TWX. This is not TWX. So then we look back up above in the proof, and we say, okay, well, if I want to keep the STW, I need to replace that RTU so that it's going to be TWX. So I would look up above and I find another RTU. Well, there's another RTU. Well, RTU is also congruent to angle TWX. So instead of writing RTU, we can write TWX, and that's what they do. They go angle STW, they keep it and bring it down, and instead of RTU, they write TWX. So instead of this, they write that. That's our substitution property. And it is in the right order. It is in the order A equals B, B equals C. So then we could say that A equals C or C equals A. So technically this could be the transitive property. But you're not going to go wrong in this situation for using the substitution property. And that's actually the one that I would recommend for you to use.